A 7¼ inch gauge Sweet Williams steam locomotive, part 67, making new valve links using 2 lengths of bright mild steel. The current valve links are really horrible things and really spoil the look of the valve gear on this locomotive. The rest of the valve gear is well made, and I'm going to try and follow suit and make the valve gear look like the rest of it. The existing valve links are definitely not made from bright mild steel. I quite like the round edges, but that's about all I like about them. As you can see from these clips, removing them was quite simple. Take out the split pin, remove the washers where fitted, and then pull the pin out. Or in this case, push the pin out with the end of a pair of long nose pliers. With one of the valve links removed from this end, it's time to go to the other end. It's basically the same arrangement, but at this end there isn't a washer. I don't know why there isn't a washer. There will be when I reassemble it. Here's a close-up of the procedure. Close the split pin and then pull it out. Quite a simple job. Now the valve link can be lifted off the pin. Although the pin isn't really fixed to the other piece of metal, which is, by the way, bright mild steel, there is enough flexibility to just lift the valve link off. I'm going to have a look at the valve link. I haven't fully written it off at this stage. I'm using a needle file to clean up the surface to see whether it's viable to make it shiny, but it's not looking good. After the needle file, I tried a piece of coarse emery cloth, and this was no good either. My lifespan is definitely not long enough to shine up these 2 pieces of metal. The good thing about cleaning up these pieces of metal is that I can draw on them. I've put an arrow on this side telling me that this is the front, and it's the outer right link. These valve links are bent, and in the next episode I'll show the bending procedure for the new ones. They need to be bent at each end so that everything lines up. What I'm going to do is use each of the original valve links to mark the positions on 2 pieces of mild steel. This mark you're looking at the moment is where I cut them to length. And to do this I use my old trusty metal cutting bandsaw. All I have to do now is lay the original parts on top of the new pieces of steel and mark positions using my deep hole marker so I can drill new holes in the right place. I'm pretty sure that the diameter of the holes needs to be 1/4 inch, but here, using a 1/4 inch reamer, which is about 45 years old, I'm just checking that it fits in the holes. When I marked the positions for the holes using the original rods, the holes were not exactly in the centre. Some of the holes were okay, but others were not. I'm checking this using a steel rule. Alright, I know that a steel rule isn't the best thing to use, but it gives me a general idea where I need to make the mark. I'm using my calibrated eye mainly for this job. And just in case you haven't seen many of my videos and don't know what I'm talking about when I say calibrated eye, it's something that seems to happen when you use your eyes a lot to do things like find centres and drill holes in the centres of things. No good maybe if you're making internal combustion engines or turbines or space rockets, but it's okay for this job. Here I've centre punched the hole and I've corrected it slightly. Now it's over to the drilling machine, and even though I've centre punched the hole, I never trust them because a twist drill can wander, and even though it started off in the right place, it can very much end up in the wrong place. I prefer this method. Rightly or wrongly, a centre drill isn't going to wander about. And also, as I'm drilling the hole, it has a very small point and I can estimate where it is relative to the position of the hole. I drill the first hole and then I turn the piece of bar round to drill the one at the other end. And again, the same principle using the centre drill. This morning I received a comment about the job I was doing repairing the 5-inch gauge Model Works pannier tank. And this viewer pointed out that the eccentric that drives the oil pump was a bit loose on the shaft. Very kind of him to let me know, even though I did notice it when I filmed the video. I noticed it also when I edited the video, and I noticed it for a 3rd time when I voiced over the video. Often I receive comments telling me things are wrong when it's just the camera angle, and I've tried to explain about lens aberration, but it falls on deaf ears. After drilling the holes through both of the rods by holding them together in the machine vise, I'm using my 1/4 inch reamer to ream the holes to the correct size. And now it is top tip time. I've owned this reamer for around 45 years at a guess, and I think it was possibly second hand when I got it. And I've used it many times over the years. Really I need to buy a new one, but here is a top tip for making reamers cut slightly oversized. I'm using a carbide tipped lathe tool along the flutes of the reamer, and this raises a very slight burr which causes the reamer to cut fractionally oversized, but as this one is worn, it makes it cut the right size. This is not my top tip. I did learn it from LBSC, who used to write articles for Model Engineer many years ago. Now when I fit the reamer in my electric drill at the lowest speed and push it through the holes at the end of the mild steel bars, not only do I get a very good finish on the metal, it also makes it the right size for the pins, with just enough clearance to allow oil to penetrate. I wonder if any expert viewers have noticed that there is something wrong with this job. These are steel pins going through steel bars. Definitely not a good combination for a bearing. This method, however, does work perfectly if the pins have been case hardened. Looking at these, I don't think they have been case hardened. I was going to make phosphor bronze inserts, but I didn't bother as they weren't present in the original links. It's not important really. When the pins wear, they can be made a bit bigger. Inserts can be fitted in the existing holes by drilling them out slightly. I'm about to round the ends of both of these link rods, using one of the pins as a guide. Then it's into the outer part of the workshop to profile the ends and make them nice and round. I'm doing this at a high speed. It took quite a while to do it, and it looks like it's very easy, and indeed it is, only if you've done a lot of this. A popular alternative for rounding the ends of rods, which is a bit more accurate, is to hold a piece of 1/4 inch diameter silver steel in the chuck of a rotary table, then round the end with a milling cutter in the milling machine, moving the link rod around it. After roughly rounding the individual rods using my 1-inch belt sander, I pushed a piece of copper pipe through the holes at each end so I could make sure that both of these were the same size and shape. And once they were, in order to obtain a better finish, I cleaned them up on my polishing spindle. And now both of these rods look quite good, particularly at the ends. I tried one of the rods in position and it fitted perfectly, although it was a bit tight. It needs bending so that everything aligns. I'll show this in the next episode. I'll remove the rod for the time being because I don't want to stress out any of the parts, and that's it for this episode. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainstream Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.